I hope you're enjoying the conference, and I'm so sad that I couldn't be there with you. To make up for it, I hope a little, I have put together this video presentation of the speech I was going to give, which should appear on YouTube. Please forgive the low production values and the fact that I do use a mechanical keyboard. Thank you so much for your understanding. So if you don't know who I am, my name's Erica Sadun. I write books, I develop apps. Right now I'm working in documentation. It's my privilege to be here today and share some stories. Today's story is going to be about work I did on the Swift programming language. I was invited to speak because I've been a contributor to Swift, and I thought this was a particularly wonderful story to share. So if you wanted to ask me, what is it that I do in life? I would say that I find developer pain points, and then I find ways where I can help developers work through them, and I can do this by writing books, by providing sample code, or by improving the tooling that they use to get their work done. All of these help support my friends, my colleagues, and of course myself, because I am an audience for my own work. So today's talk is called SE-0200 Unexpected Elegance, and it's a story about what took place during the process of adding a new feature to Swift, and I'll go through that. But I'm going to start talking about where change and advocacy begins in a programming language, and at least the early stuff kind of applies to pretty much everything you do as a developer, or many things you just do in life. So let me get started with that. I'm going to talk about how you motivate change, because change has to start from somewhere. Then I'm going to talk about the Swift evolution process. And then I'm going to talk about what it takes to create that change. And there is some depth about what it means to go into a tooling and say, I want to change how it works. And I'm going to discuss what raw strings are, because that's what SE-0200 introduced into Swift, more or less. And then I'm going to finish, I know it's at the very end, the actual story of SE-0200, but it really fit best there, where I kind of led up to the actual story. And so I'm going to start with the motivating of change. So everything in this life has defects. It doesn't matter if you're talking about something that we create, something that we encounter. Defects are sort of part of life. They're just there. They're inheritance of the human condition. So there's no product, no language, no tooling, nothing that doesn't have at least some rough edges. And it's this imperfection that creates so much opportunity to improve things for others. So let's start with do. And do is the requirement that you really understand the tooling or the software that you're working on, that you need to be a customer for your own product. And sometimes you can get lost in ticketing and forget to actually sit down with the tech that you're building from the point of view as a user. And doing and understanding is the first step for change. You should always be and always consider yourself a first-class consumer of all the tools you create, because that gives you the passion to drive change forward. The second stage is listening. And you can do that through looking at your tickets, through getting onto forums and listening in there. But I find that just reaching out and actually having conversations with developers is one of the most valuable ways to understand what might be wrong in your tooling. And finally, there's advocacy. And advocacy doesn't mean putting a new ticket in. Advocacy means taking responsibility for seeing a project through to the end, whether it's becoming a team lead, project lead, managing a proposal for a feature. It really doesn't matter how you advocate, but if you do not deliver the change that you're working on, then the effort that you have invested, obviously some of it's going to roll over to other products. It's going to give you experience, but advocacy is for the long haul. And it can be draining, and it can be wearing, and it can be easy to walk away sometimes. But if you advocate for something and you see it through till it's finished, there's nothing else that feels like that. To see your feature, your product, whatever it is you're building in life, come to reality, your vision. So what's Swift evolution? It's the process in which any user-facing feature, it doesn't matter if it's part of the language or part of the standard library, anything that changes from the user's point of view has to go through the Swift evolution process to be approved and to be incorporated into the language. And it starts off by pitching and developing your proposal. And this is where 90%, maybe more, of your effort happens, where you get on the Swift forums and you pitch the idea. You see if there are people who are interested in it. Just because you think it's a great idea is not going to be enough. And you come up with a solution and a design, and you go over this over and over and over, and it can last literally for years. It can be for months. It very rarely is for weeks. At this point, all changes to the language are pretty profound, even if they're tiny changes, and they need to go through quite a lot of discussion before you can actually put them forth. Eventually, the proposal is going to solidify, and you start to create a white paper called a Swift proposal. But what it is essentially a standards document of how the new feature is going to appear in the language, how discoverable it is, how it's going to be implemented, and so forth. Only when your proposal is fully formed can it actually enter the Swift evolution process at the GitHub repo for Swift evolution. Once it goes into the process, you can see there are all these steps where it goes through general review of the Swift community, then it goes into the steering group to have a final vote, and it may go back for revisions and so forth. It doesn't necessarily get accepted or rejected right away, but most decisions actually tend to be pretty clean. If you have a really strong proposal coming in, it will generally be reviewed in a week and then accepted into the language fairly quickly. So, if you're going to be going and changing the Swift language, there are some lessons. These are not official lessons. These are lessons that I have picked up over the years, and I wanted to share them with you because I feel that it's kind of valuable to understand what it is that the Swift language team generally is looking for. So, first of all language changes need to be really well focused. You can't create changes that are extremely widespread. They have to be very narrow in scope. The next thing is that they have to solve real problems. They're not looking for features you think might be cool. You have to justify why it's going in there, show use cases, motivation, and so forth. Next, the language changes, especially the ones past Swift 3.0. They cannot break code. Breaking changes were allowed until then, but right now, no changes, because you can't impact working code anymore. It's just not something that's going to be allowed except for extremely important major differences. And finally, language changes have to fit within the principles, the design ethos, and the mission of the language. You can't just say, oh, this is cool, take it from another language, stick it into Swift. Because if it doesn't fit, it's not going to make it through the process. So, one last feature is it's got to work. And there's a reason for this, and I am the guilty party about this. This is SE-0200, which was expanding Swift self. And it used to be that early on in Swift, you could use uppercase self when you were creating extensions for protocols, but you couldn't actually use it in a method. So if you wanted to init the same type that you were working on, you couldn't do that. And the reason, well, let me give you a timeline that explains the reason why all features must be implemented before they can be merged into the language and before the proposal can actually go through review. So I wrote the language proposal in 2006 on April 19th. Remember, I told you, this is always at the end of the discussion. The proposal part actually happens pretty fast. The review statement was for the 20th. So that's when the review actually started. It was accepted 1 week later, which is the standard time. And the proposal was implemented 3 years later. This is the reason that this rule came into place. I am guilty, but I think it was a really great positive change, and I am unapologetic for it, as I am for pretty much all of my proposals that went into Swift. So let's talk next about creating that change. Swift Evolution was part of WWDC 2015 when they announced that Swift would be open sourced and that people outside of Apple could contribute. And this was huge. It meant that as users of Swift, we had a say in what the language would become. It gave us a power and it stepped into the door of Apple, which is not really known for, being open source or having contributors outside Apple's ecosystem. This is something Chris Lattner, I believe, insisted on when he led the language design. So this was a huge opportunity to get involved. So the first proposal that was there was one of mine. It's number 7 because the Swift Evolution process had actually started before they went open source. So there are 6 that preceded mine. And it was to remove the C-style for loops. And I started review on December 7th. Open source happened on December 3rd. Obviously, I had worked on a lot of this sort of stuff over the time between WWDC and when it went to open source. So it sort of hit the ground running. And it was accepted a week later on December 14th and incorporated into the language. And this was the beginning of allowing a public discussion that continues today about what it means to have a feature, to have a proper fit into the Swift programming language. And it meant that those of us who depend on the Swift ecosystem to put roofs over our head, it's what brings home the paycheck, that we ourselves could advocate for and change the ecosystem we depend on for our livelihood, which was huge. And there's me at the bottom left. I'm the Dogbert avatar right over there. But for me, I'm so proud I was able to do this because it was a moment in my life where I could make profound changes to the way not only I develop, but that touched other developers and so many other people. And I'm just so proud that I could be part of that. And of course, to be here today and share this story with you. And this is more or less what the change looked like. On the top, you see a standard C-style for loop. It's not written in Swift, it's actually written in C. The bottom is Swift's version. This was existing. This is exactly the same code. It's exactly the same variable names. It does exactly the same work, which is to provide bitwise exclusive or across memory. And you can just see that the for-in is so much smaller. And while I don't really like the header that's for the function, and it's something that continues to annoy me to this day, you can see that the for-in loop was a massive improvement in terms of look, in terms of safety, and so forth. It was not a popular change, by the way, because if you think about it, who was using Swift at the time? These were developers who were very comfortable in their skin, had tons of C experience, and they didn't want to see a tooling that they were comfortable with leave. But it didn't fit. It wasn't within the fit of Swift's design. And there were some lessons there where we started to talk about what something was Swifty, something that fit within the Swift language. And I felt, and I still to this day, that for-in constructs are beautiful. They're so easy to read. They're well-balanced, they're harmonious, and they're joyful. Well-designed language features create healthy patterns and healthy paths, and they ensure, especially in Swift, which is focused on safety, that safe things happen when you use them. And in the C loop, with all those side effects that are possible, because you could take that loop and do lots of things, and trust me, I have done very bad things with C-style loops. That doesn't fit into Swift's overall guiding philosophy. It shouldn't have made the cut to begin with, and it was the first of several proposals that address what I call language design regrets. So, Swift was on its way to finding out what it was and where it was going, and eventually we got a very well-defined mission statement, and you'll find this on swift.org, which is the home of all things Swift. The call-outs, the bolding, is not original. I just changed them to orange to make them look prettier with the talk. But the whole mission statement, I could spend an entire hour, hour and a half talking just about this paragraph, and I don't have time. So please, I encourage you to explore this in more depth, but I can't do that today. So raw strings, what are raw strings? Originally, this was going to be interactive, and I was going to ask everybody in the audience, but here's the question. What does the double quote mark and the backslash have in common? And the answer is that both of them need escaping if you're going to use them in standard strings. And you use the backslash character like you do in very many languages. It's the prevailing way to do escaping in programming languages, as well as specifications and domain-specific languages. Using this process to allow delimiters to act as the characters that you actually want to get is the heart of what it means to use raw strings. And here's just some convoluted Swift where you see how ugly it is to use so many backslashes and so much escaping to get the results that you need. Now, some of this was first addressed by SE-0168. That was multi-line string literals, and it's what's introduced the triple double quotes. And it allowed you to use 3 in a row to begin and end multi-line strings. And it was an awesome proposal. And if you look at the first 2 names, John and Becca, you'll notice that those are my co-authors in what was the raw strings proposal. We didn't get Tyler, we tried, but there is a lot of this that tied in. And let me show you how this became the first step towards moving towards raw strings. So here's the same example as last time, but if you notice there's so little escaping needed here. You have to escape the Unicode character. You have to still escape the backslash and the tab, but everything to do with new lines and quotes are taken care of for you. You don't have to do that anymore. So it was a major step forward in terms of putting content in that looked like how it would be used, that could be better inspected, and so forth. However, raw strings take this notion a step further. If you're using raw strings, you can cut and paste text directly into code, which is important for a whole bunch of use cases, which I'll explain in a bit. In a normal string, backslash, backslash, backslash n is the backslash character followed by a new line. But in raw strings, it's actually 3 backslashes followed by the letter n. It means whatever you put in there is literally what you get. It gives you the text that you want, not the text the compiler thinks you want. So the whole point of raw strings is to limit compiler involvement in the strings. So there's a whole bunch of reasons to use it. Metacoding, which is really my #1 reason right now for using it, helps you create apps that produce code. And I have done this for any number of apps, ones that help with time strings, ones that help with creating color extensions, and there's a lot. Oh, Sprite Kit, I've done a lot for that as well. Pedagogy, when you're teaching programming languages, and the programming language, by the way, does not have to be Swift. It can be any language, and the raw strings are for metacoding as well. It could be any language you want to deal with, programming languages, specification languages, domain-specific languages, and so forth. Regular expressions, until we got regular expressions, so nobody uses raw strings for that. Data formats, DSLs, and building test cases, extremely useful. I think raw strings are wonderful. I'm a huge consumer of them. They're kind of an edge case as far as the language is concerned, but those of us who use them are passionate about it because raw strings really make our lives easier. And whenever I start talking about this, people, the hands start raising and it's like, oh no, what are you talking about? If you're using strings directly and you're using strings all over the place as part of your app as opposed to just putting them into a strings file for translation, that's bad. You shouldn't have decentralized strings. You shouldn't be using strings. And, there is a point to this. And here is another question, which is, what does this code print? And it's string, this is Swift, using a format specifier. And this is really Swift. I promise you it's Swift. You can even see that it runs on Vision OS. It is a real call. Promise, Girl Scout promise. So what does this string produce? %2.3D and the value 15.2. I'll give you a few seconds to think about it. And the answer is it produces 3 zeros. And I put a URL here that links you to the documentation for format specifiers, which is used here. And the reason this happens is, of course, because D is used for 32-bit integers, and F, which should have been used, is used for doubles. And the value being passed is a double. So you see an example that this existing call is violating type safety. It's extremely unsafe. The problem here isn't really about using string data. The problem is that it's using them badly and unsafely. And one of the worst offenders for that is controlling runtime behavior. So if you're ever using strings to control runtime behavior, you're probably doing it wrong. I talked already about the type safety violation because there was no agreement between the format and the argument, and you can't mandate that agreement. There's no way to test for it or anything. There's also issues with string-based control for time formats, string formats, auto layout, which is still a thing. I wrote an auto layout app last week. And almost inevitably, anything that you put control into that's a string will require what I call an arcane incantation. You have to go into the specifiers, or you have to go into a lot of documentation to get it right, and you almost never do. And there's no way to test that you got it right. Well, or there are a few, but they're not very good. So generally, it's a really bad way of using strings. Basically, avoid magic constants whenever you can. And if you have to use them, make sure you have a trusted type that vends them and that is extremely well trusted and tested and so forth. Always localize 2 well-trusted types to provide those for you. But raw strings are not runtime string control. They aren't used to control runtime behavior. And they help when you can't read bundled files. For example, when you're creating command line utilities or shipping some API stuff. And yes, they do have string problems like testing, but because they're so much more readable, validation is a lot easier. Having code review and all those just goes a lot smoother. I recommend a lot more eyeballs, but while triple quote strings made complicated text easier to read, raw strings takes this to the next level because there's no compiler being involved in interpreting that string. So to summarize, I love raw strings, and SE-0200 brought them into the Swift language. So finally, let's get to SE-0200. And it begins by it being returned. John, my friend, John Holworth, was the one who did the raw string proposal SE-0200. And the core team felt that it was appropriate for the language because it's a great feature, but that the design wasn't Swifty. And it had gone through so much. And at this point, with the return for revision, John threw up his hands and it was like, no, I'm not doing this anymore. And it was like I had to beg him. Here's the original design, and it's letter R followed by double quotes, just a normal string. And the letter R would happen whether it was a triple quote string or a single double quote string. And this is directly from the Rust programming language, which is great. So many Swift features were influenced by it, and a lot of people who do Swift also do Rust. And it works great in Rust, and we love it in Rust, but it wasn't Swifty. It didn't really feel right in Swift with that little R hanging off of the leading edge, kind of like a little worm dangling over there. It just didn't work. So it went back to John, and I really wanted this, so I was begging him, please, let's do a redesign. And he said, okay, fine. You want it, you do it. So he basically put the project onto me. So John is an incredible developer, really, really gifted. And he's the one who the three of us depended on for creating the tool chains, because we were testing these throughout development. We would come up with a design, he would put it into a branch of the compiler, give us builds of that tool chaining, and we would be actually testing it, seeing how it works, seeing how we liked it, and so forth. The other person on the team is Becca Royal Gordon, and she was the one who knows languages. She is just brilliant when it comes to languages. So I basically have background in user-facing design. Becca has a languages background, and John is our compiler guru. And we all decided to work together to make this thing happen. And John's condition, of course, was that I had to be the face of this and basically provide protection from the Swift community, because he had just been overwhelmed. So the first thing we had to do is study the state of things in other languages, not just Rust. As for using designs from other languages, let me share you a rather famous quote. And that is, good artists copy and great artists steal. And what makes this even more humorous is that it has been attributed to nearly everybody. There are more people this quote is attributed to that are possible, which means that each of them probably had to copy it as well. So here's the starting point for our design. This is a language survey of raw strings, and the two columns that are important here are, is this feature possible in Swift? And is it Swifty? Does it fit into the overall design? And very quickly we found that there were really only two possible design approaches. The first was single quoting, using just a single quote, not a double quote. And the other one was the way that Rust used pound signs, and specifically multiples of pound signs that are balanced on each end, so you can remove ambiguity by just adding additional pound signs. And there really weren't other ones that fit, so that made the initial design much easier, even though honestly it did take quite a while to come just to these two, because everything you're going to see as these tables I put together by hand, and I did the research, and Becca started with a couple of languages, and I thought it was great, and I really just dived straight in and started just doing a complete survey as much as I could. And some of our initial designs before we got there, before we got to the language survey, were pretty awful. I had been doing a lot of attribute proposals. Attributes are the things that start with the @ signs. And so my first one was @raw, it's Swifty. And the reason I have the stuff at the bottom of this slide is like my headspace was so into attributes. I had the grammar for them just in my blood. And so I pitched that, and you know what? I was the one who came back and really said why it was bad. It separates the value too much from the assignment. So the let value has this big honking word between the equal signs and the actual value, and I really didn't like that. But this was our first step. Here's one from Becca, and it too didn't really work. It said instead of using the attribute, it would use the pound sign with raw and basically kind of do a functional approach. It didn't go far. Here's one that said, okay, we're going to limit it to the triple quote strings, and this was one that actually did not come from inside the team or inside our particular group, working group, and it's one that a lot of people really liked on the forums, everybody except me. Any number that's greater than 3, as long as they're matching, would be treated as a raw string as opposed to being just a normal string. And people really piled on this. They really wanted it. And I didn't want to give up single line strings because at that point there were no regular expressions. And I didn't want to do regular expressions on 3 lines. And I found some conversations. I went all the way back to find them in time of our original discussions in the working group. And I really felt that in terms of our solutions, the only ones that we really could go forward with were the single quote and the pound sign. And the other ones that had been pitched on the forums just weren't going to work. And I use a few phrases in these screenshots, and I wanted to find a few of these phrases that I was using here. The first one is Swifty, which means that it has the appeal, the design aesthetics of Swift. Something that fits into the language is Swifty. The second one is Swiftable. In other words, is it possible to construct this feature into the compiler? So I don't know if people still use this term, but for a while it did have traction. Swiftable is something that could be incorporated into the compiler. And then Rusty, and the way we were using it is it followed the balanced approach, the multiplicity of delimiters that matched on each side of the string. And the one that was the multi-line one with many of the double quotes, that was Rusty because it had that balanced multiplicity. And here's how raw strings work in Rust to the full extent. You can use pound signs with the little letter R. And if there's a conflict like there is in the first line of this example, if you notice the quote, pound sign, which will not compile correctly, it will error out. All you have to do is add another pound sign to reduce the ambiguity. They're balanced on both sides. And it was just a brilliant move from the designers of the Rust programming language. And I want everybody to remember that edge cases are critically important in language design. Always pay attention to edge cases because it is what makes your compiler robust. So finally, on June 25th in 2018, we basically had the design down. We'd already gotten feedback from the team about burning the single quote. They wanted to use it for much more significant purposes, and they asked us not to use the single quote in our design. And the pound sign was, it was Rust had it. The only thing we were doing is removing it from the little r, getting rid of that little r, no problem. The compiler was still able to disambiguate it. And we could use it for both single line and multi-line quotes. We were totally cool with that. So this is the design we decided to go forward with. I went to the forums and I announced that this would be our final design. And we wrote the first draft of our final proposal. And this is what the solution looked like. You can see it in the lines that have start with content. And in here you can see that they're using the raw string format. You can use raw strings with items that need escaping, as in the first one, or items that don't need escaping, because I always find that it's better to use a consistent style in blocks of code for readability purposes. However, notice all the plus signs in this code. We didn't like that. The reason raw strings are raw strings is the compiler stays out of it, and that means you don't have access to string interpolation, you don't have access to Unicode characters, you don't have access to new line characters and tab characters and so forth. And normally you don't think about string interpolation because the whole point of raw strings is to create the atmosphere that you're saying, hey compiler, please, hands off. But string interpolation is one of Swift's standout features. It's one of the things that really makes strings great. And so we started bugging John saying, can we still have string interpolation? And, he was like, the whole point of raw strings is not to do that. And in Swift, it's not just string interpolation. In Swift, our design excluded interpolation, nulls, Unicode, tabs, new lines, and returns. And, it was like, John, could we possibly bring those in? So we did put the proposal all together, I put the proposal all together with this first final design. We had several final designs, as you'll see. And it was a great design for raw strings. It fit perfectly into Swift's aesthetics. It was based on Rusts. We ran it, we used it, we loved it, but we really wanted to have string interpolation. But to point out, the design we had was visually balanced, and it was very simple to use and to understand. So we were really happy with it. It had standard string support, multi-line support, and it had the exclusions because that's the role of raw strings. And so we kept coming back to this chart I had made saying, could we have this one and maybe this one? And if so, how do we do it? And this is where Becca really shone, because Becca languages. And so she started kicking the wheels, and she came up with what is the current design. It's the language design you see in Swift today, and it's beautiful. It's just a gorgeous design, and this is how it went. So we would have escape sequence extension for raw strings. We'd take whatever delimiter you used outside the quotes, whether it was single double quotes or triple double quotes, and we would combine it with a backslash. This would maintain Swift's criteria of balance, and it would be an expected and understandable system. It could be parsed by the compiler, and it would provide the injections into the raw string. And at that point, we talked back and forth about, well, do they come first like they do at the beginning of strings? Because they're the first thing you see when you start parsing these raw strings. Or do they come after? And John and Becca really wanted the first design, and I really fought for the second design. And my reasoning was, if you are inspecting one of these strings, when you see that backslash, it immediately says that you're dealing with an escape situation. And because of my background in user design, I won. So my design is the one that's currently in Swift. And so because of that, this is our final design. And so a new line that was in a string with 2 pounds as its delimiter was \pound n, and this extended to all escape sequences in the language. The number of pound signs would always match, so you always had wonderful balance, visual balance, emotional balance, all of those things. But it gave us flexibility, and the number of use cases they just totally exploded. And it was just a beautiful Swiftie design, and really, it's Becca's design, and she deserves that credit. So, we next handed it off to John to see if it was Swiftable. And he went off, I don't know, it was probably later in the evening, and he came back fairly quickly because we were getting our copies of the compiler pretty soon after, each time, because his turnaround was amazing. And probably by about 10 p.m., we had it and we were using it, and it was so good to use. It did everything we wanted, and it was amazing. And it just worked. And I know somewhere there's a slide that talks about this, but when John, let me see if the slide comes up. If it doesn't, I'll tell the story anyway, but let's just start here. So what we had was extending escape sequences for raw strings, and there was just one problem here. Because the compiler was involved, and it was very Swiftable. Oh, here's the one I was going to tell you about. Let me back off of that a bit. It was possible to extend the escape sequences. It was Swiftable. John did it, and we were using the compiler. And when he came back, and I am totally paraphrasing here because John is very British, and he would never use this phrasing. Holy cow, the whole code base just collapsed, and everything just came together into a single coherent model. And it really did. It was really, to cut a long story short, when we changed the delimiters, we made Swift simpler. For me, it was raw strings, but it wasn't really raw strings. It was custom ones. And the new approach didn't just work. The compiler became better at using these custom tokens with strings because there was no special casing. All the special casing we were originally going to add to the language, which would have complicated the compiler, it just went away completely. And that meant that everything just squooshed down in the way that strings were being handled. So with this design, strings worked whether there were 5 pound signs, and please never use 5 pound signs, 1 pound sign, or 0. They were all the same thing. They were all just Swift strings. So it did the work of raw strings in terms of you could just paste things in. And like the triple quotes, the difference in the delimiter meant that there was no delimiter confusion. You could put in a backslash, you could put in quote signs, you could put in all the things that you needed, but it was something new. So it was no longer raw strings, because raw strings, their contents are not processed by the compiler, and ours were. And so what we were creating were raw strings. And I personally feel what we created was better than raw strings. So it was an unexpected outcome, but I think it was a perfect outcome. So I did make a lot of bad jokes at the time that we had created medium rare strings, that we had created well done strings. That was my favorite. It was the right solution for us. It was the right solution for the language. And it was a right solution for the Swift community. It really did fit into the right design and the mission. It was super flexible. It was powerful. It met all the Swift design guidelines. And While we originally were trying for a less bad, less awful redesign of the original proposal that was returned, what we ended up was a feature that was elegant. It was beautiful. It had harmony. It surpassed everything that we had in our original goals. So we renamed it from raw string escaping to enhancing string literals, delimiters to support raw text, a title I hate for so many reasons. First of all, it was no longer raw text, but we sort of felt we had to keep that in there. Second of all, there is a typo. It should have been string literal delimiters. And finally, it really shouldn't even have had any of those things. What we created was new custom delimiters for string literals in Swift. That's what it really was. So on August 29th in 2018, SE-0200 was accepted by the Swift core team because there was no steering team at that time. And the feedback was positive, as Doug Greger mentions in his posting. There were concerns about the use of the term raw string, which those reviewers were completely correct. It was inaccurate because we were using compiler stuff. However, the core team felt that support for interpolation was one of the great strengths of the proposal. And the issue was one of terminology. And it was the best outcome we could hope for. It was embraced. It was really strongly reviewed with, it was almost unanimous in terms of people not voting against it, for which we were extremely gratified. And this is the Swift programming language 5.9.2. I took this as a screenshot off the web just a short while ago. And that's the URL that leads to the documentation. And you can see it's extended string delimiters, which is a much better way of referring to this. I want to thank you all for listening to my talk. I wish I could have been there in person. Swift design and the language are things I care deeply about. And I really am happy that I'm going to get to share this with you on the YouTube channel for the conference. Thank you all very much for listening to my talk.